Hello, can you hear me at the back? Yeah. Okay, so I come from the north of England and I have a very unfortunate accent, which means that most of you won't have a clue what I'm talking about for about 5 minutes or so. So the first 5 minutes I'm just going to talk about some stuff so that you can start to parse my accent, okay? Because it's really hard to tune into what I'm talking about. And just shoot back here, this slide here, there's a great book called What I Talk About When I Talk About Running, which was actually a follow-on. It's actually Haruki Murakami, and this is from the great book called What We Talk About When We Talk About Love. And actually these slides are framed against the chapter headings of What We Talk About When We Talk About Love. So I've stolen the headings from this very famous book on the right to frame some of my thoughts. So there's not a lot of words on here, okay? There's lots of pictures. And actually the first story in this book, well, one of the stories in this book is called Viewfinder. So where I come from. I used to be a mathematics teacher for 10 years. I taught high school children in the UK. I walked away from that job when I fell out with the head teacher, who tried to ask me to do more teaching than I was required to do on my contract. And I said, "You have my notice." And I walked away after 10 years, and I then went to work in a university. In the university, I then had to get a PhD, so I did a PhD in human-computer interaction because I couldn't work in the university without the PhD. And it's an interesting point because at that moment, my life sort of changed. And I often just think back and think, I wish I was teaching maths again, you know, because I really do like kids and I like teenagers, okay? I had a relatively unusual upbringing. I was brought up in a family of 3 children. My parents were hippies, and no, they didn't drug use, but they worked as radiographers doing x-rays, and they used to bring syringes home. And we used to spend most of our bath times, me and my brother and sister, squirting syringes all over the bathroom with water everywhere. And of course, syringes are such playful objects. It's a great shame children don't get so close to syringes anymore. And we would squirt and we would squirt and we would squirt and we'd suck and we'd have a great time. And there was something very interesting when I think back to the amount of fun and the amount of mathematics, if you like, that was in the syringe. We didn't know at the time, we were just children, okay? We were just children at that time. And the interesting thing is that when you're a child, you also get things horribly wrong. So another thing I remember from my childhood is that in the UK, on a Thursday in May, we used to vote for our democracy, you know, we would vote, and my parents would go voting, and they would go out to the school, we'd get a day off school while they voted, and we were always taught as children that democracy mattered. No, I think my father was a raging communist, and we would stay home, and our parents went to this mysterious place and went voting, but we thought they went boating. And we thought the school was filled with water. And they went around in little boats. And there was something about some kiosks. And we got it all wrong. And children get things wrong, don't they? Children get things wrong all the time. Hopefully you're starting to understand what I'm talking about now, so I'll give you a bit of the context of where I'm coming from. And there's something interesting about school. So then I went to school, and I fell in love with my maths teacher. My maths teacher was absolutely gorgeous. You know, he was a really, really gorgeous man. And he was called Mr. Cole, and I can still see him now. He probably is like 90 now. He's probably lost his hair. And I also had another maths teacher who I didn't fall in love with. But both of these people were great teachers because they could both teach maths really well. And of course, then I became a mathematician. You know, I fell in love with a maths teacher. They both taught maths well, even though one was terribly not gorgeous and one was absolutely gorgeous. And then I started falling into maths. And that's how I became a maths teacher. So I think one of the key things about what you're trying to do here with constructionist toolkits, or certainly one of the things I got from Stanford when I was there a few weeks back at the Fablab conference, is that we're wanting to inspire scientists. And just as I was inspired by my maths teachers, it was something about the medium that mattered. So we're starting to talk now about the theme of what I'm supposed to be talking about. So I think there's something really important about understanding how we make things attractive. And that's really core to creating something really cool in a sort of science agenda. The heading there is called Mr. Coffee and Mr. Fix-It. I don't know how many of you are maths teachers. Is anybody a maths teacher? Yes! You are to be saluted. Okay. My maths teachers always smelt of coffee. There's something about teachers and coffee breath. But that's kind of interesting. But think about it, Mr. Coffee and Mr. Fix-It. That's just the titles from the headings. And then I went off to be a maths teacher, of course, and I started to do maths. And if you teach, how many of you actually teach maths to 14-year-olds who aren't very good at it? Okay, so a couple of sympathizers here. So I used to teach maths to children of all ages, and you would get really good kids who could really do maths. That was easy. And then you'd get the kids who couldn't do maths at all, and that was hard. And every time you wrote fractions on the board, they would go, I can't do fractions. And you would say, yes, you can. No, we can't. Yes, you can. What is hard about fractions? And they would have all these blocks in their heads about things they couldn't do. And these children were full of things that they couldn't do. Children spend half their lives thinking of things they can't do, and it's really sad. And I used to take these really hopeless children, the really hopeless ones who couldn't do maths, to save their lives, and I would teach them trigonometry and algebra, because I figured that you can teach anybody anything if you really sort of get down to it. And I used to teach children to do nice little, right-angle triangles. I love right-angle triangles. I used to teach children to do right-angle triangles by explaining to them how to get to a sensible answer. And they didn't need to learn any formula. I remember doing this. I'd say, what do you think the answer is going to look like? Let's just try all the formulas we can feel like, stick everything in everything, and we'll just pick the answer that seems closest to the truth. And you will always get your algebra, you'll get your trigonometry right if you use that basis. It works. You don't need to learn sine over cos and all that kind of thing. You don't need to learn any of those things. But the interesting thing there was understanding, if you like, that getting to the answer is not necessarily the same as understanding the problem. Sometimes we get to the answer in quite unusual ways. And I think the fabrication movement is a really interesting place to play about how children can get to answers without necessarily understanding everything that's going on. And it's a really playful space. It's really hard to play with a right-angle triangle. It's a lot more fun playing with some batteries and some bits of wire and some conductive thread and so on and so forth. So I think that's a really interesting thing about how we could open up possibilities for children to do more than they used to be able to do. When they always were worried about the problem and understanding how it all came together. I had a classroom. When I taught as a maths teacher, I had a classroom. It was actually a fabricated classroom. We had these, we had a baby boom, and so they shipped in these sort of cardboard classrooms and stuck them in the playgrounds because there was no room for there wasn't any money anyway. There's never any money for education. So anyway, we had this sort of cardboard classroom, and I was right by the field. And in my school, we were not allowed to take the children out of classes, right? You had to stay in the classroom. That was the rule. And it was a glorious day, and I had 13. They were called set 8, which kind of tells you that they weren't set 1. Doing mathematics. They were age 14, 15. And we climbed out of the window with our chairs, because nobody could see us because we were like on the edge of the field. And we climbed out of the window in our chairs and we did our maths in the field that particular day. And I think there's something interesting about adventure. And that was my most adventurous teaching moment, I think, the day we climbed out of the window. And the head teacher never found us. If there are managers here, okay, I'm sorry. It's okay. My manager never came out of his head teacher's office when the children were around. He only came out when the children weren't there. He was a bit scared of the children, I think. And so there's something about being adventurous. And the participatory movement, which is children creating their own things, designing their own things, getting involved in design of technologies, and the construction movement, these two things both collide in quite a nice, adventurous space. And I think putting adventure in classrooms is quite an interesting problem. It's a problem for managers, and it's also a problem for teachers. I can remember as a teacher, you know, the head of maths, he wasn't the head of the school, like I say, he only came out when the children were all busy teaching. But I remember the head, you know, sometimes they didn't like it if your classroom got too noisy. You'd get sort of a bit of a disapproving look, you know. What's going on in there? That can't possibly be learning because there's lots of noise going on. And yet you do need to be a little bit adventurous, and I think there's something interesting about designing spaces and activities that allow adventure, but also instruction. And I think that's partly what's happening here in this workshop, in this series of workshops about bringing fabrication and participation and this sort of space together. So that's an interesting space. These are, by the way, all headings, like I say. So then I went to university, as you do. So I did I'd done my teaching. I went to work in university. And in the university, the children became students. They're all still children at 18. They really are. And they sat in rows like this. And everything, you know, kind of became quite dull. And I was supposed to lecture to them. And they were supposed to listen. And they were supposed to learn. And there's almost no participation in that environment. And yet universities still believe in lectures. That's kind of interesting. And our university even insists that our students come to lectures. It's kind of the big thing, attend the lectures. And yet the real learning takes part when you do things. We all know that. And so the real learning takes part when you stop sitting in lectures and you start doing things. And our university, we're less bothered about that. That's kind of interesting, you know. As long as you turn up to lecture, you've got the learning. And to the extent where our students in universities think if they've got the PowerPoint slides, they've got the learning, which is very scary. And what's even more interesting is that this is dripping into education spaces. So, winding on a few spaces, I have 4 children. Yeah, I know I look far too young. And they're all grown up. And they're all grown up. I even have a grandchild. And my children are all grown up, except for my son, who is 18. And he's not really grown up yet at all. And he's just been thrown out of college this week. As I speak, on Friday, he has been told that the chemistry teacher no longer wants to teach him chemistry because he has a bad attitude. And he doesn't really have any attitude, to be honest. He's just very, you know. And he's quite smart, actually. Tragically, he's actually quite smart. The thing is that he's been thrown out of chemistry, and I rang the head teacher, and she said, oh, well, it's just the chemistry teacher. We still want him to do maths and physics. And, but the chemistry teacher doesn't want him in the chemistry class anymore. So he can learn everything that he needs on the Moodle site. That is exactly what she said. She said, everything's on the Moodle site. I said, oh. And then she said, and he can do his homework and the mark schemes are on the Moodle site. And I said, oh. I said, so what is the point of your teacher? I said, why are you bothering with your chemistry teacher if you're telling me that my son can learn everything he needs to know from the internet? And of course, he's not participating. So I think that's a really important sort of thing. And it seems to be drifting into education, which again is something to rise against and say, no, that's not really what we want. My father, like I said, was a bit of a radical. And every single week of his life, he did the Observer crossword. The Observer is a quality newspaper in the UK. It has a nice hard crossword in it. And every week of his life, he did the crossword puzzle in the Observer. And he sent it off when he was in Africa. He sent it off to places. He never, ever won the prize. Never won. You used to win £25 if you were the first correct one pulled out. But he would spend all week thinking about the crossword puzzle. That's what he did. He took it very, very seriously. It was a really important thing to him to do the crossword puzzle. In the work that we do in participatory thinking and participatory design work, we take participation as quite a serious thing. We actually want to keep doing it again and again until we get the very best we can out of children. So let me tell you how I ended up doing participation and how I ended up being where I'm doing with child-computer interaction. So went to university, yes, did my maths, did my teaching, and then I found myself in this university environment needing to do a PhD. And I wanted to go back to something serious. I wanted to think for my PhD study about something that would make a difference. I had my 4 children. Daughter number 3 was a little bit hopeless at talking. So she used to say, she learned to talk by the car. I don't know if any of you have got cars that talk. I had a car that talked at the time she was little. And the car would say, fuel level low, check as soon as possible. It was a Renault. And the fuel level was always low because I had 3 children and I couldn't afford it. Anyway, so she would sit in the back of the car, age 2, swinging her feet in the car seat, going, level low. And the poor child never had much chance at speaking. And so I wanted to get involved in something that would worry about her educational future. Because at that time, everybody said computers were really going to be the big thing. We were all going to be talking to computers. And I thought, oh no, my child won't be able to talk to the computer because she's completely unintelligible. And so I thought, this is really bad. This is really bad. I need to worry about this. And I then went off to do a PhD on speech recognition in children. I gave up after 3 weeks on speech recognition in children because it didn't work. And I went into handwriting recognition in children as it happened because speech was never going to work anyway. And from that point on, I got involved in this child-computer interaction space, which is the study of technologies for children, and specifically the study of how children might participate in the design and evaluation of their technologies. So that's the research field that I kind of work in. I have a very nice research group full of young men, 33-year-olds. They all remind me of my maths teacher, so that's okay. And we go off and we do lots of studies with school children, little tiny children, medium-sized children, teenage-sized children. We're not that fussy. We do work across all these different things. And in this space, there's a raft of information about how children participate in these things. Many researchers are very naive about educational thinking. Many researchers come in here with all sorts of half-baked ideas. A lot of them haven't studied child development. They haven't done sort of studies in of all the things around education, children learning, all that kind of thing. And there's a lot of naive thinking. So there's a lot of people that just think, oh, we go and ask children something, and then the children will give us great ideas, and then we're all happy. That's very naive thinking. And one of the important things about this idea of participation being a serious thing, like my father with the crossword, is that we have to keep trying and getting this right. So our ideas as a research community about participation in children really could do with some solid thinking from people like, people in education and so on. So I shall come back to that. This is my beach. This is where I run. This is Southport in England. This is the West Coast. And you may know that last week, England, I don't know if you had the same over here, England had a bit of an issue with the water and the tides. We had a lot of problem with our water. This is my beach. The water only ever comes in Southport, obviously twice a day, but it comes in very, very, very shallow. This is one of these expansive beaches that goes on forever. And you very seldom see the water in Southport Beach at all. Very, very seldom. When it does come in, it comes in whoosh and whoosh. If you blink, you miss it. Last week, it flew right over the seawall, and there was like carnage, and the cows drowned, and it wasn't a great experience. And the water's really interesting, isn't it? Tides are really interesting. You sit there and you take no notice of it at all until it decides to do something rather extraordinary. And the water peaked up, something to do with a combination of three things. There was the wind, and there was the sucking, and there was the tide or something, and three things happened, and all the water went mad. And I think with participation with children and constructing things with children, we've got to think that 90% of the time, and I have this in participatory design with children, 90% of the time, 99% of the time, everything will be very ordinary. And every so often, something extraordinary happens, like the water comes in and flies over the top of us. I'm told I've got to go a bit faster, so faster we go. My children, my 4 children, all used to win the sack race at school. So the sack race was when you put your feet in sacks and you jump. Do you do that in Denmark? Yeah, my children won this loads and loads. They won it every single year. They were the ninja sack racers. All right? They were like sack racers to die for. My children never win very much. They're not very that way. But, you know, nice when they win something. And they won the sack races because they had spent all of their summers camping. And they had learned the art of having your feet in the sleeping bag and jumping in the sleeping bag all over the place. And that's just what you do when you camp. In constructionist thinking and participatory activities, I think there's something very interesting about what we can transfer out of all these spaces into each other's spaces. So, when children participate in design and they sketch things and they come up with ideas and they have ideas about design thinking, there's something interesting about how that might inspire them in other spaces, maybe even in the right angle triangles. We don't know. There's something interesting about sticking together electronic bits, whether that will help them later on put a button on the shirt, who knows, you know? So there's something interesting about transferring knowledge from one place to another, and the sack race for me kind of did that for my children, which is rather neat. The materials that we use inspire what we do. And so some of our work in our research group, we've been looking at how things like Play-Doh, for example, might inspire how children might design. If you build with Play-Doh, if you structure things with Play-Doh, that will then potentially have you designing things you can make out of Play-Doh. Yeah? If you play with slime, we've had children designing with slime, that runny slime and pipe cleaners, it will tell you what you're going to end up designing. There's a bit of an interesting problem about the constructionist toolkit. If all you give children are pieces of electronics, will they only ever design electronic things? And that was the sort of main thrust of the paper that I think some of you have seen. If you give people a blank space and say design anything, they can design things they can't make. If you give them things that they can make things with, they tend to design things you can make things out of the things that you've given them. I mean, that's just the nature of things. So one of the interesting problems, I think, for the fabrication movement is how we inspire children to think what they can possibly design with the products that they are given, rather than be constrained by the products they've got. That's a problem that many of you will already know. If you work as technology teachers in things like, you know, resistive materials or, you know, whatever, all sort of stuff, plastics and all that kind of thing, then you will know that problem because you'll know that the children will only use what they have available to them. I used to refer to something called the chemistry lab syndrome. When I did chemistry, I used to go to chemistry and the chemistry teacher would leave all the things out and you knew you had to use them all because that's what the person had put on the desk. You knew you had to use the Petri dish and the stirry thingy because it was all laid out for you. And there's something interesting about letting children have more things than maybe you even imagine they might need. So I think an interesting challenge for the constructionist movement is how much stuff you should give children and whether you need to give them stuff that they don't need to use to help them be inspired to think outside the things that they actually have. We're getting near the end. This is my village where I live. This is my church. My church has been there forever. My daughter got married here last September, which was very nice, and the red arrows flew past. That was free, we didn't pay for it. It just happened to be the weekend when the red arrows flew past. That was quite nice. Churches are good places to think about old practices. And you walk around an old church and there are graveyards and there are old stones and there's always a cornerstone. It's certainly in English churches. This stone was laid by such and such a body, Sir Wilfrid Frank or something like that. And somebody lived and somebody existed in these old spaces. And in these old spaces, you remember all the old craft practices. And crafting is something that has been falling out of education, certainly in the UK. Craft practices have sort of fallen out. One of the things that we do when we do participatory design with children, we're amazed how many children can't cut out straight even. And they can't work out how to fold bits of cardboard together. And they haven't learned all sorts of standard craft practices. So an interesting constructionist thing is the craft practices that underpin and the craft practices that grow out of constructing things, sticking things together. You'd be surprised how many children can't even put Lego bricks together anymore. It's kind of scary, you know, they can do this, but they can't do simple things. I think we have 3 more to go. I'll go very, very fast. This was Mousetrap. Anybody remember Mousetrap? Anybody remember Mousetrap? Absolutely great game. And Mousetrap was quite interesting because it's kind of basic physics. It's physics, it's marble run, it's physics. The ball has to go a certain way. You've got to get the angles right. You've got to understand a lot of things to make that work. Again, for the constructionist movement, rather than the participatory design movement, there's a bit of an underlying problem about understanding the sort of scaffolded things that go together. There used to be a great computer program called TIM, The Incredible Machine, which was full of physics. A wonderful program. One of my daughters actually rolled back all the computers so she could put it back on the computer. It was a wonderful machine, wonderful game. So there's something interesting about how much knowledge of popular mechanics you need to get into your constructionist movements. I have 2 more to go, I think. Designing, therefore, is about materials. Children will gravitate towards certain things. So when we do participatory design with children, Alison Druin refers to this as some sort of big bag approach. I have no idea what it is. It's just the stuff you've got lying around. It's the stuff, isn't it? You get the stuff, you get your stuff out, and they will pick all the stuff out. And so if you have fluffy little balls of pom-poms, the children will stick pom-poms on everything. And if you say, why is that pom-pom on there? What does that mean? They will come up with a rational answer for it because they've stuck it there. It doesn't mean for 1 minute that's why it's there. It's because you've asked them a question and they've stuck things and they stick things all together and then they explain why they've stuck them there and often they haven't stuck it for any sensible reason. Another challenge for the constructionist space is how we understand why children are sticking things together, the way they're sticking things together. Because they're sticking things together for one particular reason and they will tell you why afterwards, but it might not be why they did it beforehand. This is also my village. And my village, two Christmases ago, the river froze. And the river runs straight out to the sea. It's very unusual that the river freezes. This is the river. This is our boatyard. And it looked really nice. And then all of a sudden, it all just collapsed and all the boats fell down because we had ice across the top. You must have this in Denmark, the same thing sometimes. Everything collapsed and, oh my days, the boats all fell, sunk to the bottom, and there was all sorts of damage. And I think the key thing about the constructionist movement is that it might look really fun, but if it just sort of caves in and collapses because there's nothing underneath it, it will be a little bit like my destructed boatyard. It'll be a place where there was a lot of potential, but when you look at it now, you can't see a way to sort of sail out of it. You can't get beyond the carnage that is in that space. So I think there's something really challenging for all of this makey movement. I think there's something really challenging about how we get the pedagogy right, how we understand what's actually going on, and how we don't end up with just something that is just fun. And we have the same trouble with participatory design thinking. There's sort of an idea that it's a great thing for children to do, but nobody's quite sure why, which is a little bit tragic. And that is the end. I just about got through it, yeah. Sorry about that.